Today we're going to go over a general demo of Lightning AI and how it helps researchers, companies trying to develop AI much more quickly, get access to compute, and effectively integrate AI into their products and services. What do you need to actually start out with AI? One, you need compute. Two, you need to have your data, you need to have an environment, and you need to have code. So the way that you get compute is, of course, one, by either using Lightning Cloud, or if you wanted to use any other cloud, you can always bring in a cloud account in order to use stuff from AWS, clusters that you might own, other cloud services, clusters, etc. So once you add that account, the way that you actually spin up an environment in order to start working on that compute is to start a studio. So I have a studio that started here, and I can go and begin my training and experimentation. So right now we're connected to a CPU that you can see here. And all I need to do now is get my code in and connect my data. In order to bring in code, researchers love to use GitHub, as all people should. So you can just bring in your code from GitHub, integrate it into a very familiar looking VS Code. If you prefer to use other IDEs, you can connect to Cursor, Windsurf, integrate Claude code into the terminal here, or of course SSH into any IDE of your choice, which researchers love. So now I just need to connect my data. And how do I do that? I go to the drive, which is going to be shared between all of the studios in this given team space, which is a space for people to effectively do projects, having it logically separated so that there's no overlap in people's work and everything is able to be streamlined to production. So in order to add data, you can obviously connect your own buckets here from S3, GCS, other services. You can also create agnostic storage folders that can go to any cloud without egress costs. And then of course, you'll be able to access that from the IDE that you choose. So if I was to go add an S3 bucket, I want it to be accessible from my cloud here. I can say imagenet-tiny, give it a name, and then I can add that bucket. And then now I have that bucket within here and I'm able to view and go through all of my data within my workspace. All right, now that I have my environment, my code, my data, and a compute environment that I'm going to begin working in, I can start to smoke test my code to make sure that when I send it to a GPU instance, there's not some syntax error that has me bringing it back down and wasting valuable time and resources, not doing experiment and just doing researcher overhead. So I'll go ahead and smoke test this, Python train. We'll be able to see that the model starts to train. All right, now I can see my model has gotten to the training phase and I know that this code is actually proper to move into a GPU environment. So typically what would happen is that I would have to go contact some administrator, give them the compute that I wanted, and then I would have to wait maybe days, maybe weeks to get access to that compute. How would I go about that with Lightning? Very simply, all I have to do is go up to my selector here, go to the GPU I want to go to, and when I'm going to do that switchover, you can see the breadth of compute options that we have. So not only are you able to use your own cloud accounts, you're able to use other neo clouds, you also have access to compute from the Lightning Cloud as well, which you can see we have live wait times for all of these experiments. Our enterprise customers will have zero wait time because we are going to guarantee them access to the certain number of GPUs that they would want. But of course, they have the option to use GPUs from all across the GPU world, which can be very useful for being able to very quickly do development and run experiments, all the way from your T4s to your B200s and beyond as we continue to grow. Let's just call it the L40S for now, and I'll go and request that asset. And when I do that, it'll give me a countdown. By the end of that countdown, all of my code, all of my data, all of my environment variables and dependencies will move over to that new compute resource, which is what I actually want to be working on. While we're waiting on that to turn over, two more things that are great for researchers to be able to do their work more effectively is one, the ability to collaborate. So I can actually invite coworkers into my environment so they don't have to recreate my environment just to help me out in some sort of debugging or development exercise. I can just come in here, copy a link, send it to one of my researchers, and I'll be able to see their live cursor, and they're actually going to be working in my environment like a Google Doc or a Google Sheet that you've shared with a few different people, which can be very useful for researchers. The second piece, which we'll talk about a little more, is the plugins. There's a lot of overhead involved with highly parallelized experiments, doing many experiments at once, or actually scaling up your training to do multi-machine training. With Lightning, we're able to facilitate that with a system of, you can think of them as iPhone apps. So if I wanted to do multi-machine training, I could install that plugin. I'm able to do everything from highly parallelized data processing to experiment management to multi-machine training, easily spinning up GPUs, spinning up web apps for people to test out, evaluate models, visualize results of an experiment, or even serve results of a model to teams outside of the AI team, which is a very popular use case in the biotech world, being able to integrate a model into an application and bring in your scientists to actually push data into that application and get results out. So a very easy way to do that. All right, and now you see that we've acquired that L40S. It automatically switched that over for me. We've been able to shift all of our data, code, and environment over to this new compute instance in a matter of minutes, which can obviously save a lot of time when trying to bring models to production for these AI teams. And now I'll do the same thing. I don't have to do any other work. I just go into the previous directory that I was in, and I can click up on the arrow keys here, bring in my last command, and go do that training once again, this time on a GPU environment. And now we can see that model training much faster on my target machine. I can go ahead and optimize this training run for this machine and wait for it to get to completion so I know it finishes. But from here, what we're going to actually want to do is run a bunch of experiments at once. So that process of going and procuring a machine, debugging until you're actually able to run a successful job, could happen for 12 experiments in a matter of weeks. With Lightning, what I'll be showing you in a second is the ability to run, in this case, a few experiments at the exact same time, which obviously is a compounding factor. Depending on how many experiments you need to get to production, we're able to help you run them much more quickly. And the way that that's done is through our batch jobs. So one of the plugins we have here is batch jobs. I'm going to use that in this script to say I've optimized for my L40S machine. I have all of my different experiment tuning parameters that I want to test out to figure out what is the perfect training recipe for this model. And then, of course, I will be able to execute on that. While this first one is running, I can come in here and run my Python sweep jobs.py. And what you'll see over on the right side is all of those jobs spinning up at once. So now in a matter of minutes, instead of having to wait to run a bunch of sequential one-by-one experiments, I'm running 8 of them at once, orchestrated through the Lightning platform, which is a much more complicated version of just running sequential experiments. But now I have them all running. They're all on my target machine. I have all of the analytics about who ran it, when it was ran, what the actual command was. This is going to be very important for when we actually do our big training run through the multi-machine experiments. All right, so that is running right now. I actually have some of those experiments that I've already run. So I can come in here to our native experiment manager and we can see all the results of the experimentation here. I have some instances where the model took a little bit longer to train, but may have gotten to a better loss. And I can sort of say, what are the trade-offs I'm willing to accept? Do I want to train faster? Do I want better metrics? Do I want to do more experiments to find an even better sweet spot? You have a lot of freedom because we're giving you so much time back. But let's say that I'm optimizing for speed and I'm saying, this seems like a pretty good experiment for me. So I can come into this experiment and I can see what was the recipe that I used to run this experiment. I have all of the about here. I have my command that I used to run within this studio. And then of course, I can just take that command and I can go back to my studio and I can say, all right, now I want to scale that training up. Whereas orchestrating training on single machines is a little bit more simple than multi-machine. Multi-machine is actually a very hard thing to orchestrate. You have to do much more custom coding, much more custom implementation, and of course it takes more machines. So getting access to those clusters without having access to Lightning Compute can once again take weeks, maybe months, depending on the size of the cluster you want. Combined with access to our compute and the ability to orchestrate using our platform, we can actually scale that training up. So I'll come into the multi-machine training here. I'll do a new training run. I'll replace this command with the command that I ran within Lightning. And then I can say, all right, I want to run it on a full node, and I want to run it across, let's say, 8 nodes of L40S. So now we're about to orchestrate 64 GPUs to do this training run. And I can come in here and make sure that that command is as I planned. And then I just click run. And now we've created a multi-machine training job where I've been able to parallelize to find the perfect experiment. And now I'm able to scale vertically to run that fine-tuning job, that pre-training job much more quickly, fully orchestrated by Lightning AI without you having to go and contact your administrator, having to build a platform to facilitate this type of work. Lightning takes care of all of that under the hood. So now let's say that training is complete and I'm ready to go test and evaluate that model. How would I do that? Well, I'm going to get the weights out of that multi-machine training run, and I can send them automatically to our weights repo here. So I have that perfectly fine-tuned version of this model, and I can version this model. I can see, where it came from, who submitted it, etc. But then when I want to actually go and use that model, I can download that model into my evaluation studio or into a studio to spin up an API for me to run requests against when evaluating. And so I can go over to my API Dev Studio here, where I am bringing in that model. I can still do all of the debugging that I would need to do to make sure that this version of the API works without me sending it and then getting failures back. The same paradigm holds for developing model APIs for you to run against. So once I'm ready and I've been able to spin up my API, I can do the same thing. I can switch over to the GPU that I want to use to host this API, and I can do that switch over here as well. All right, so now I've spun up my API, and I could test this locally, but I can also expose it via our API builder to anybody else who may be running an evaluation application. So I have this link, and I can take this and I can bring it into my evaluation application, which can be running in a separate studio or in the same one if you want. But I can come into my evaluation application. And now within this studio, I've built my evaluation application, so I can come into the application window here. So now I have my evaluation application running in a separate studio. I'm going to evaluate my fine-tuned model against maybe an open source model that I'm trying to replace and get out of the tokenomics that are giving so many companies problems right now. So I come in here, I choose the API I want to test against. I have my URL where I'm hosting the model, and I'm able to run my benchmark. And as I come back into my evaluation studio, I can see the usage from that benchmarking happening live within that studio. So somebody who is monitoring the API while this is happening is able to get all of the metrics they need from this evaluation running in the studio. And now I'm able to see all of the metrics comparing my fine-tuned model versus a closed model that I'm trying to replace. I know all of the things I need to do to make sure that I am improving the model if it needs to be improved or how well it does on certain tasks. And now let's say you love the model that you've trained. Well, of course, then I can go and promote that to a place where my teams can bring it into production. So I'll go back into my API Dev Studio. I'm able to containerize this model API using Docker. And then, of course, I'm just going to be able to promote that model. So once I run it in Docker, I'm able to send it to our container registry here, where I have my container, and my team can, of course, go and download this model. And now they have that model in production. They've been able to go from easy access to compute, connecting their data, setting up their environment, connecting their code, running many experiments at once, getting the best recipe for a larger training run, execute that multi-machine training run, and then go and evaluate the model that they've trained against the model that they're trying to replace, whether it is a previous version of that model or it is an open source model they're trying to get away from the tokenomics of. And so now we've gone end to end. And the nice thing about it is that, of course, you have all of the provenance over how much was spent. If I look at my activity table here, I'm able to see all of the usage for this team space. I'm able to see who was doing what, how much each activity costs. And then I'm able to effectively bill back and control budgeting for the whole org. Within the admin center, I have the ability to allocate different amounts of credits to team spaces to further their research and their work. And then, of course, manage all of the different clouds, storage, and activity across the organization. So hopefully this is a good demonstration of the power of Lightning AI. Thank you for watching.